You are holding a baseball in a park. You let it go, and it drops to the grass. Gravity just pulled that ball down to the earth, right? That is what we have always been taught. It makes perfect sense. Wrong. What if I told you the earth did not pull that ball at all? We are about to break apart the greatest illusion of your everyday life. You are going to discover a truth about our universe so bizarre and so beautiful that you will never feel the ground beneath your feet the same way again. Let us go back to school for a second. We all learned the story of Isaac Newton and the apple. The apple falls. Why? Because the earth has mass, the apple has mass, and big things pull little things toward them. It is an invisible tether, a universal attraction. We call it gravity. We are taught that gravity is a pulling force. And you believe this story because your body tells you it is true every single second of your life. Think about it right now. Feel the weight of your body pressing down into your chair. If you are standing, feel your heels sinking into the foam of your sneakers. Feel the concrete of the sidewalk pressing against your soles. You feel heavy. You feel like you are being anchored, dragged down toward the center of the earth. It is relentless. You carry this invisible backpack of weight wherever you go, from the moment you wake up to the moment you lie down. That feeling is the earth pulling you, right? It makes perfect, intuitive sense. It is the most undeniable physical sensation you will ever experience. This is common sense. This is the bedrock of how we navigate the physical world. But here is the problem. Your senses are lying to you. That feeling of heaviness? It is a complete illusion. That invisible tether? It does not exist. Newton gave us the math to predict exactly how things fall, but he did not actually understand why they fall. He even admitted it himself. For centuries, we just accepted this invisible pulling force because the math worked. But then Albert Einstein came along, and later, Richard Feynman explained his work with a clarity that is almost terrifying. They looked at that falling apple. They looked at that heavy feeling in your shoes. And they realized there was a massive, gaping hole in the story. They realized there is no pulling force at all. So, if the earth is not pulling you down, what exactly is happening to you right now? To understand this, we have to do what Einstein did. We have to run a thought experiment. Imagine you wake up inside a metal box. There are no windows. There are no doors. It is just you inside this sealed room. First, imagine this box is drifting in deep, empty space. You are millions of miles away from any planet, any star, any pulling force. What happens inside that box? You float. If you let go of your coffee cup, it just hovers there in the air right next to you. You let go of your keys, and they just drift right beside your hand. You feel completely weightless. There is no up. There is no down. This makes perfect sense to us. There is no gravity out there to pull you. Now, let us change the scenario. Imagine that exact same metal box is back on Earth. It is an elevator at the top of a massive skyscraper. Suddenly, the main cable snaps. The box goes into free fall. You are plunging straight down. What happens inside the box now? You let go of your coffee cup. What does it do? It hovers right next to you. You let go of your keys. They float right beside your hand. Why? Because you, the cup, the keys, and the box are all accelerating toward the ground at the exact same rate. Here is the question that shattered physics. It is a simple question, but it changes everything. If you are inside that box, can you feel the difference? Can your body actually tell if you are floating peacefully in the emptiness of deep space or plummeting to your doom down an elevator shaft? Think about it. The sensation is identical. You feel perfectly weightless in both. Your coffee cup floats in both. There is absolutely no experiment you could possibly do inside that closed box to figure out which reality you are in. It is impossible. Einstein realized this was not just a trick of the mind. It was a profound, fundamental truth of the universe. Floating in empty space and free falling in gravity are not just similar experiences. They are in the exact same physical state. When you are falling, you are not being pulled by a force. You are experiencing the absence of force. You are simply coasting along in the natural state of the universe. But wait, if falling is the natural state, if falling means no forces are acting on you, then what in the world is happening to you right now as you sit perfectly still in that chair? Let me give you the answer, and it is going to sound completely insane. Think about being in a fast car. You are sitting at a red light. The light turns green, the driver slams on the gas, and what happens? You feel thrown back into your seat. You feel a heavy pressure against your body. But is a mysterious invisible force pulling you backward? No, the car is accelerating forward. The seat is rushing up behind you and smashing into your back. The force you feel is just the physical seat pushing into you. Now, bring it back to where you are right now. You are sitting in a chair or standing on the floor. You feel heavy. You feel that exact same pressure against the bottom of your feet. If floating in a free-falling elevator is the natural state of zero force, then standing on the solid ground is the exact opposite. You are not at rest. Not even close. Here is the twist that changes everything. The ground is rushing up to meet you. The floor is accelerating upwards. It is smashing into your shoes. The chair is driving up into your body. You think you are standing perfectly still, but you are not. You are accelerating. Right now, the surface of the Earth is pushing you upward at exactly 9.8 meters per second, every single second. Let that sink in. You are not being pulled down by gravity. You are being pushed up by the ground. The Earth is acting like a giant elevator, constantly accelerating upwards, driving the floor into your feet. That feeling of weight, that heaviness you have carried your entire life? It is not a pull. It is just the physical sensation of the Earth getting in your way. It is the ground physically stopping you from following your natural path through space. This breaks everything. It shatters your entire intuition about up and down, about motion and rest. But the second you accept this new reality, a massive, glaring problem pops up in your head. Think about it. If the ground in New York is accelerating upwards, and the ground in Tokyo is accelerating upwards, and the ground in Australia is accelerating upwards all at the same time, then the entire planet must be expanding, right? The Earth must be blowing up like a giant balloon. But it is not. So, how is that even possible? How can the surface of a sphere accelerate outward in all directions without the sphere getting bigger? In normal, everyday geometry, it cannot. If the surface of a balloon accelerates outward, it pops. But Einstein realized our universe does not use normal, everyday geometry. Space is not a rigid, empty, invisible box. Space is a flexible fabric. It bends, it warps, and mass, like our giant planet, changes the very shape of that fabric. Imagine a massive bowling ball sitting in the middle of a trampoline. The fabric dips down, it curves. Now, imagine space itself acting exactly like that. The immense mass of the Earth is literally squeezing the space around it. It is pulling the invisible grid of the universe inward. Space itself is slipping down toward the core of the planet, like water spiraling down a drain. Because the fabric of space is constantly rushing inward, anything caught in it wants to ride that wave down to the center. So, to stay in one place, to not be crushed into the core, the solid ground of the Earth has to constantly push back against that inward flow. Think of it like running on a treadmill. If the treadmill belt is moving backward, you have to run forward just to stay in the exact same spot in the room. You are expending energy. You are accelerating, but you are not actually moving forward across the room. That is exactly what the surface of the Earth is doing. The geometry of space is flowing inward, slipping down toward the center. And the solid crust of the Earth is pushing outward, acting like the motor of that treadmill, matching the speed perfectly. The Earth is not expanding. The invisible space around it is curving inward. So when you stand on the sidewalk, the concrete is physically shoving you upward against the inward curve of the universe. That heavy feeling in your legs? That is not gravity pulling you. That is the physical effort of the ground keeping you from slipping down a cosmic funnel. You are literally being forced to climb an invisible hill every single second of your life. And this realization changes everything about what it means to just exist. Because if standing still means you are constantly being violently pushed upwards, what actually happens when you let go? When you jump off a diving board, or when that baseball leaves your hand, you think you are falling. But according to the universe, you are finally stopping. The moment your feet leave the ground, the pushing stops. You are no longer accelerating. For that brief second in the air, before you hit the water, you are at rest. You are experiencing the true, natural state of the cosmos. You are floating in the fabric of space, just coasting along the curve that the Earth created. The ground is still accelerating upwards toward you, but for a moment, you are free from it. This is not just some neat physics trick. This is the reality of existence. We are beings born onto the surface of a massive object that is relentlessly bending the space around it. To survive here, to build cities here, to just stand here, we have to constantly fight that geometry. Every structure we build, every step we take, is an act of resistance against the inward flow of the universe. When you look at a mountain, you are not just looking at a pile of rocks. You are looking at billions of tons of matter physically shoving itself upward against the curve of space, fighting to not be swallowed into the core. When you feel tired at the end of the day, when your legs ache, it is because you have spent the entire day accelerating. You have been running on that cosmic treadmill without taking a single step. So the next time you drop something, do not think of it as falling. Think of it as surrendering. It is letting go and letting the geometry of the universe carry it. And the next time you stand still, remember what you are actually doing. You are not at rest. You are riding the surface of a planet that is violently accelerating outward into the fabric of space. But if mass bends space this much just by sitting there, what happens when something massive starts spinning? What happens when two giant stars crash into each other? How far do those ripples in the fabric go? I'll leave you something to imagine. So, the next time you drop your keys or watch a leaf drift toward the grass, try to see it for what it actually is. You aren't watching things fall. You are watching them find peace. You are watching them stop fighting the invisible curves of the universe and simply exist in their most natural state. It is a strange thought, isn't it? That to be still on Earth is to be in a state of constant, violent acceleration, while to fall is to be perfectly at rest. It flips everything we thought we knew about our home and our bodies. We spent thousands of years thinking we were being pulled down by a heavy, mysterious cord, only to find out we are being pushed up by the very ground we stand on. This is the beauty of looking closer. The world isn't just a collection of objects and forces. It is a symphony of geometry, a delicate dance between mass and the fabric of space-time itself. Every step you take is a conversation with the cosmos. Every breath you draw happens because you are being held up, pushed, and supported by a planet that refuses to let you slip away into the dark. But there is a final piece to this puzzle. If the Earth is curving space around it like this, what happens if you have even more mass? What if you pack the weight of 1,000,000 Earths into a single point? What happens when the treadmill of space moves so fast that not even light can run fast enough to stay in place? What happens when the fabric doesn't just curve but completely snaps? That is a different story. For now, I'll leave you something to imagine.